Sweet. Welcome to 4844 implementers call number 21. Yeah, like I was saying, there's a bunch of spec stuff on the agenda today. And then after that, we can chat a bit about DevNet 5. Quizu, I hope I'm getting their name right, shared a little tool on the agenda that was pretty cool as well. And then if we have time at the end, I might want to talk about the readiness checklist a bit, especially in the context of like all the conversations we saw in the Discord about some stuff around libraries and just, other tests we want to do to make sure that we're actually moving this to prod with all of the bases covered. I guess to start though, so on the last call, we discussed merging get payloads v3 and get blobs bundle v1. I don't know if we ever got a PR for this, the execution APIs. Is anyone aware of one? Okay, so it seems like no. I guess I'm curious in terms of just the client implementations. Oh, okay, nice. Okay, we got it. Okay, I think it
looks like it's merged. The one the
Yeah.
multi-post 402. Yeah.
Yeah. Okay, sweet. I missed that one. Thanks for sharing. Okay, great. So we've merged those. We have the PR. Anything else on this? And I believe we had this as part of the DevNet 5 spec, if I'm not mistaken. Yeah. Okay. Okay, next up then, so on the last ACDE last week, we discussed EIP-4844, which introduces the optionals SSD type. And then we agreed to move that EIP forward and make a couple small changes to it to make it work with 4844 a bit better. And Ethan listed those in ETH Magicians. I don't think Ethan is here today. I believe it's a holiday where he is. So he listed all of these changes. There's been a PR as well that was opened against 4844. This is actually quite an old PR, but that would need to be merged now. I guess. So assuming the changes that are listed there in Ethan's ETH Magicians comments get done to the EIP, so the sort of 3 bullet points he lists, and we go ahead with this PR 6495 on EIP 4844, is there anything else that we'd have to do to kind of align 4844 with the optionals EIP?
I think that's the only optional. There's only one optional field in the blob transactions. I think that's it.
Yeah.
I mean, there's other things we need to do, like around the hash tree root domain string. That's the other EIP, but I think you listed in the agenda already. So I assume we'll talk about that next.
Yes. Yeah, that was the next thing, but I just want to make sure the optionals were good. All right. Yeah, Lacan, do you want to make the case for getting rid of optional in 4844?
Yeah, I mean, we talked about it a bit, and I think we talked about it specifically in Austria, and it's just one of these things that, we add a new transaction type. We've tried to retain all of the previous behavior of the transactions, but in this case, this is such a specialized transaction. I don't know if having the ability to create transactions from the blob transaction is important. And I don't know if it's something that's making things harder. I wonder if it's even necessary.
Just to be clear, so you said create transactions from the blob
Sorry,
transactions. Did you mean?
create contracts.
Okay, got it. Yeah.
Yeah, I mean, I don't think that it necessarily needs to have the create behavior. I mean, one might say that the create behavior that we have is not really ideal. I mean, I would probably make the argument that it would be nicer to have a transaction that is a create transaction, not the to address was nil or none, and therefore it is going to create a contract.
I'm curious if anyone else has opinions about that.
I think the sorry, go ahead, Alexei.
Yeah, just wanted to ask about difficulty. How it makes more difficult? In what measure?
I mean, we're spending time trying to figure out how to, serialize and Merkleize the optional value. I think that this is supported by libraries. I'm not really sure the exact state of the SSD libraries, but it's, one of these things that we're trying to specify, and B, some just additional code paths that we have to support in the actual 4844 transaction. And it's just like another thing that we need to think of. And for a lot of reasons that I'm like forgetting all of them right now. I mean, if we think about like what maybe the future for EOF is, we're going to have, more specialized create transaction types. We already have create opcodes for creating transactions. Like there's a lot of ways of doing these things. It just seems like this is a good time to try and show a little bit of restraint and, not have everything be like fully compatible with previous transaction types. I think the one argument I've heard against this is Eton's idea of having a normalized transaction. So if we end up having this normalized transaction type, then we kind of need to define optionals anyways. And so, and basically the idea of the normalized transaction is that you have one format that represents all of the different transactions that are possible in the protocol. So if that's the route that we end up going down, maybe it doesn't really make sense to drop it from 4844. But I think ultimately this is a very specialized transaction, and like I marginally prefer dropping optional.
I more or less agree with Light Client in the sense that when we will actually implement normalized transactions, which is normal transactions in SSD format, basically we can enable at that time. I don't think 4844 transaction as of now needs an optional too.
But couldn't the current blob transaction become that normalized one? Right, if you just drop the one blob requirement and it can represent everything, right?
I think the problem is with the mempools. Like we're building this very specialized transaction type around the idea of blobs and the idea that blobs are going to be, more challenging to propagate and share with peers. So I like on a theoretical point, like, yes, that's probably the case. But I think based on what Peter has said in the past and what it seems like the discussions have been, that if we do want to have a normalized transaction, we are going to create some other transaction type with a more clear discriminator that this is not a blob transaction.
I guess Roberto and Mofi, from Base and Optimism's perspective, are you fine with that? You're sort of the users of this, right? Like, so
I don't have a strong opinion. I mean,
yeah,
I like simplicity, so kind of narrowing it down is preferential in that respect. But it's hard to predict, all the use cases of this. So there's
right.
a natural reluctance to start constraining things. But yeah, not somewhat ambivalent about this, I guess.
Right. Yeah. I mean, fortunately, you do have the ability to still create contracts via the opcodes. Really, the only functionality you miss out on is if for some reason you have some piece of your design or architecture that relies on creating contracts from EOAs that you own the private key of. And I'm guessing that's just probably not the case for anyone.
Yeah, it seems like we go back and forth on this a bit about, you know, whether it should be more specialized versus general. I just like a decision to be made, I guess. Do you think there's anyone that's not in this call that might have a strong opinion about this, Tim?
So I think Matt and Ethan are the two people with the strongest opinions. As far as I can tell.
Yeah, probably. It would be good to get Ethan to say what his thoughts are.
Okay, so I guess yeah, I guess maybe let's chat about this async on the Discord and see. Yeah, see what he thinks.
Yeah, I think we have a little.
Yeah.
Well,
Sorry.
right, we're going to have to do another DevNet, so I think we have a little bit of time to figure this out.
Yeah. I just want to make sure that, like, yeah, we don't sort of circle around this over and over again. So like I feel like if we can get like his thoughts in the next day or two, then, you know, by like the ACDC call this week, we can just all have agreed and you know, potentially just remove the optional from 4844. And I guess if we did that, then it's not clear that we even need the EIP as part of Cancun generally, because it's the only use of SSZ, I believe. But anyways, we can have that discussion on Lockcore Devs as well.
Yeah, I mean, I think if Eton agrees that if we do a normalized transaction type, it would be a distinct one from the existing blob one, then perhaps we're all aligned that we should get rid of it. But anyway.
And I think it's not clear to me. Yeah, it's not clear to me that there's consensus within the client teams that like a generalized transaction is a good idea. Transaction type is a good idea.
Yeah, no, definitely not consensus around that. But if we were to pursue it and it would be a different transaction anyway, then we may as well constrain the blob transaction now, I guess.
Right.
Kind of.
Yeah. Okay, so let's assume that, you know, unless Ethan has like a strong objection, we move forward with removing the optional field from the 4844 type transaction. And obviously we're not going to change that on DevNet 5, but as we get that ironed out, that would be what we would do on DevNet 6. Okay, and I guess relatedly, like the next thing I had on the agenda, which we covered on the ACDE last week, is the EIP-4844, so the signature scheme for SSZ, and there's comments in the chat about that already. Yeah, I'm curious, what are people's opinions about that and how we should move forward with it?
I was wondering why add fork hash to the transaction domain.
I think Eton left a comment that that's how it's done in the consensus layer. I'm not familiar with that though, but he asked the same question in the chat. I mean,
Okay.
So he was asking what the motivation was, but I don't have the answer. Hopefully someone here does.
Yeah, I don't know exactly what the fork hash looks like for the CL, but in this case, it looks like the fork hash only protects it. You know, sorry, the fork hash in this proposal that Eton has, whatever this EIP is, it only protects it against a world where a competing chain has the same genesis and introduces the exact same transaction type in a fork later than canonical mainnet. Other than that, I think it's kind of a moot point.
Well, I sort of agree in the sense that basically this transaction is not really fork dependent. So it's not that, there needs to be an expiry of the transaction when a new fork will come on.
Yeah, okay.
So,
I guess that's why it's on the CL, right?
yep.
Sorry, can
Yeah,
you
so
repeat
you,
that? I didn't follow. I'm trying to get in the notes. What was the reason it's in the CL?
So in the CL, basically, when a new fork comes on, some messages become old, and basically new messages are required. So you sort of expire them, and this is the mechanism to expire those messages.
yeah, I don't think that we have that problem on the EL. And if that was something that people wanted, then, it's something that would need to be thought about a little bit more, because we go from a world where your transactions don't expire on fork boundaries to a world where they do. I'm sure there's some unintended side effects there. Also, enshrining the CRC32 checksum into the protocol is probably not something that we want to do, because right now the proposal just says use the EIP-4144 fork hash specification, which was designed for dev P2P, and then enshrine that into the protocol. So I don't think that we really want to add more cryptographic functions into the protocol. So we might consider a different option. Otherwise, maybe just set, to be compatible with the CL, set fork hash to some static value. And then one day in the future, maybe we change it or you utilize something different, but I don't really see the point of it for the transactions right now.
Yeah, it's similar to how BLS change execution changes messages are sort of formatted with just a fixed fork. So I mean, nothing really changes. So those messages can live forever. So yeah, as of now, it doesn't make any sense to bring fork domain into the EL land to sort of expire the messages.
I linked to the ETH magician's question that Eton raised. Maybe we could continue the discussion there. I mean, it sounds like we should get rid of it though.
Yeah, sounds good.
Okay. So aside from basically the fork version, the Genesis hash, like I guess, yeah. Aside from continuing that conversation on ETH magician, is there anything else we want to figure out with the signature scheme on this call?
I mean, I guess like maybe just more of a broader question, but does it make sense to really bring the same signature scheme that validators use into the EL? Because right now we kind of have these two worlds. EL, you sign your messages with ETHSA over the signature hash, and in the CL you have a very specific mechanism that has like the domain and the fork hash and all these things. Does it make more sense to try and define some sort of signature scheme that's more aligned with the EL? Because like I can imagine a world where we don't really ever add any more transaction types, and we have like 3 transaction types that are implemented in this very specific way, and then we have this one special 4844 transaction type that looks more like a consensus signature. And that just doesn't really seem like something that's really ideal from the perspective of like execution layer developers to have like a totally different format they have to learn, and for all of the hardware providers to support this like stranger signature scheme.
Isn't the idea to like swap over all at once we're ready to SSZ everything?
No, we can't ever swap over the signature hashes. Because we kind of have the assumption that we're not going to force all of the hardware wallets to upgrade, and all of the users who have hardware wallets to upgrade their hardware wallets.
People do update those though, so it's not impossible.
Yeah, but we've like debated this a fair bit in the past, and I don't think that people are going to be supportive of a change that makes it impossible for someone who has a hardware wallet from 2017 to sign a message without updating their hardware wallet.
Yeah, and I think
There's
in the
like-
past we've even had more extremes version of this argument, which is like you've already signed the transaction and you threw your hardware wallet
Right.
away, right? Like
Yeah.
you're just waiting to broadcast the signed transaction.
I think like maybe it's possible to have some precompile or some specialized operation that takes an old signature hash and instantiate a transaction based on that, and then switch all of the transaction signature hashes over to some SSE thing. But I think like the most likely situation is that we just never are able to fully move away from the RLP signature hash.
Yeah, I guess I don't know. I mean, what would, and I think one of the problems that I guess this proposal is solving is the chance for collisions across chains. I guess there's probably a simpler way of achieving that objective. Is that kind of what you're thinking, or?
I don't know. I think that you already, actually, I don't know. I kind of forget the exact reason Eton was explaining this, and I didn't quite understand 100%. But I think that there are simpler things that we could do. So, a silly example I thought of earlier was imagine that you just compute the hash tree root of the transaction, sign that, and then to get the transaction, let's see, you compute the hash tree root, and then you change the upper byte to the transaction type ID. So now you have like domained your signing hash to that transaction. That's kind of what the domain is doing. Like there's a lot of this machinery that's happening. Like if we drop fork hash, really the only thing that all of this machinery is doing now, besides like making it look like a CL signature, is that it's adding the transaction type information to the signature. And so like there are simpler ways of doing that.
Yeah, so I think the case he was explaining was that there might be another change that introduces an RLP transaction of the same type, and introduces potential for collisions that way, which is obviously quite remote. But
yeah, I mean, if we're introducing RLP transactions of the same type, then we've made a mistake.
Yeah, I mean, I think he's saying another, EVM compatible chain or something might do that, right? Beyond our control.
For sure. And yeah, I mean, there is this issue, I guess, which I guess that's what the Genesis root is avoiding.
Yep.
Okay, so I guess, yeah, it's not clear to me what the next step is here, or I guess how much, like how valuable it is to keep, I guess, yeah, it probably makes sense to keep discussing it on each magicians, but I'm
I
a bit weary of like, yeah. Sorry, go ahead.
I mean, I guess I almost hate to say it, but I mean, maybe we adopted SSE too prematurely. Or I mean, I hate to even back up further, but
Yeah.
I mean, if we're kind of half adopting it, does that even make sense? Should we just have stuck with RLP until we kind of figure out this broader story? I don't know. I'm starting to have concerns, but
Right. So we refactor all of 4844 to use RLP.
all right, just ignore that.
Yeah.
I'm thinking
Alex. Oh, yeah, please, Andrew, go ahead.
Well, we now we include chain ID into the transaction, so maybe we can, if we want to achieve this, to solve this more limited problem of avoiding clash between like the same transaction ID but different format on different chains, maybe we can serialize like prefix transaction serialization with the chain ID instead of like Genesis hash or fork hash.
Doesn't the transaction serialization already have the chain ID?
Yeah, but I think Ethan's point was because like you can have SSD serialization and RLP serialization and whatnot serialization, and even they all use they all include chain ID, but then because they are in different format, there is no guarantee that the same binary serialization would be different, or like they potentially, like a single binary representation can still be reinterpreted on different chains with different chains IDs that use like different formats. But if we kind of include, so we have this transaction type prefix, and then maybe we somehow add chain ID to the prefix in some similar format like big endian, zero stripped or whatnot, then we can exclude chain ID from the main serialization and solve the problem of like clash between different chains.
But then wouldn't we have to ensure that it's serialized at the exact same point as the RLP encoding? Is that what you're proposing?
So yeah, I'm proposing to, I think how how type transactions work. We prefix, so we first for the existing say 1559 transactions, we serialize them into RLP, and then we prefix the transaction type byte to the RLP serialization, right? So I'm thinking, what if we like, so we have this transaction type prefix, and then we have another prefix with a chain ID outside of the SSD serialization, and then we have the like the following will be SSD serialization and or RLP serialization and whatnot, and we can promote that as among like EVM compatible blockchains as a way to avoid clashes, and we also can make sure that the special prefix for chain ID doesn't coincide with any valid RLP serialization, things like that. I'm just thinking of a way to solve the more limited problem of avoiding like clashes between different chains.
How it is different from a case when chain ID is the first field in SSZ?
I don't know how SSZ is serialized. Is it like when you have the first field, will it be the first?
If it's fixed size.
Okay, so I guess if it does not, if it and for RLP that will be Yeah, okay, maybe but then can we reinterpret the same thing in RLP as RLP?
You'd have to
Uh,
flip the Indianness
mm,
of it.
my view is we can, because right now, I mean, the signature is composed after doing a hash of the serialized transaction. So basically, if there is an RLP that is same as the current transaction and the signature matches, that means that we have a solution to finding a pre-image problem. I mean, it feels like that to me. I mean, the hardness of the problem, I mean, it's very hard.
and sorry, we had hash of what?
So to compute the signature, we hash the serialized transaction, which is prefixed
Mhm.
with the transaction type. So I mean, to find a RLP transaction that matches with this as well as the signature also works out. I mean, the problem, it feels to me that is the same problem as finding a pre-image of a hash function.
Well, I think it's a weaker problem because like theoretically, you know how SSZ works and how RLP work. So like you can potentially the potential attack is that you can find identical SSZ and RLP serializations. Well, it's mostly theoretical, I guess.
But would the signatures be valid? I mean, both in RLP and SSZ domain.
I thought Eton actually had a demonstration of it. My recollection could be wrong, but anyway.
Yeah, we need
But
Eton to
but it's not
complete
as
these
simple as-
conversations.
Yeah, unfortunately he's out today, but yeah, it's unfortunately it's not as difficult to do as finding a hash collision, for example, but I can try and look that up and add it to the notes.
I mean, adding TX type should take care of that, but yeah, want to see what Eton has come up with.
Okay, I'm not, yeah, I'm not quite sure where this puts us. Oh.
I think this is an example of a different thing that we're talking about here, though. This is an example of getting two hash tree roots being the same value, just due to the fact that the first example doesn't have a power of 2 items, and we're talking about RLP versus SSC. So maybe there was a different example, but this was the one that I was remembering.
Yeah, I might have them confused as well.
I don't know. I don't mean to like throw a wrench in things, but I feel like we're putting one foot in the door of SSZ and we're not going the full way in some cases. And so I'm just trying to think like, what is the best way to ship 4844 where we ship it quickly, we do the things we want to do, and we don't do things that need to change in the future. And I think transaction signing is, I don't know, maybe one of these things.
If
It seems like this is a big enough change that we're always gonna have, you know, some problem like this though. So either we don't do it or we
Right.
like and wait how to do it all at once. Or we do kind of possibly make some compromises today so that, you know, it lays the groundwork for the future.
And I think realistically though, when we say we waited, we do it all at once, this is like we delay, like doing it all at once will not be the top of our priority list for like the next few years, at least, right? So it's like, what's the cost of waiting, you know, say 3 years for this to happen all at once, or having something that's kind of in between in the meantime, and potentially also having to deal with it again in like 3 years.
Yeah, but I guess it seems the main goal that Eton was trying to solve was to try to get us to 6404, where we eventually have a fully Merkleized transaction route in the block header, and you can access pieces of transactions. So maybe we should
Right.
strive for kind of the minimum change that achieves that.
This is kind of like in a weird space though that's separate from that, because this is more like signature hashes and it's not really seen by the protocol other than whenever you verify the sender of the transaction. So we can kind of do whatever we want here. I guess, you know, maybe we're spending too much time thinking about what the right thing to do is, but ultimately we could just simply RLP serialize the 4844 elements and kcheck hash them with the type prefix and sign that message, and that would be the most parallel with what we already have, not affect our ability to do any 6404 related things in the future.
How is that much different than what's currently implemented?
I think it is pretty much what's currently implemented in terms of SIG hashes, but we're not right now talking about changing the way that we do the SIG hashes to be much more similar to the CL, which we're not really trying to be CL compatible as far as I'm aware. And it doesn't really affect our ability to do 6404. So we're kind of like trying to figure out a new way of doing execution layer transaction signatures, which is fine. But I guess the question is, should we just do it exactly like the CL does it just for compatibility for that reason? Or should we think of a better way that fits better within the design scope of the EL?
Right. So I guess I was asking if we don't want to pursue, you know, if we decide to keep it simple, what we have implemented now in DevNet 5, where it hashes, you know, does a hash of the serialized form with the type bit using kcheck. Where does that break, I guess? Is that not an adequate solution?
I think it's an adequate solution. I think the only thing that's a little bit weird is that it's not the it's not really the way that we hash SSZ values. So it's kind of unique in that sense. And so if we are going to make this an SSZ object, and then we, you know, calculate the RLP values of these things, this sort of breaks the assumptions that you might have around an SSZ object. I don't think it really breaks anywhere, because you don't create proofs against a signature hash. It's really something that's not seen by users in any meaningful way. So I think it's okay in this case, but the most correct thing to do would be to calculate the hash tree root of the SSZ object in some way, and then you know, compute a signature over that in some mechanism. And I think that's what this EIP is like really going for. The problem is that it just directly takes what the CL does and applies it to the EL transactions, and there are things that we don't care about, like the fork hash, as we're finding out.
Would it is there a difference on L2 side whether to create block transactions with SSZ or with RLP?
I didn't catch the first part.
So for For L2, is there a preference of RLP versus SSZ for blob transactions?
I think the only thing I've seen raised in the chat is what Mofi mentioned, which is the one nice property SSC gives you is you can get at the blob version hash without having to know the entire transaction schema. But that's a consensus layer advantage, not an EL advantage. Yeah, so if we're not, for example, taking advantage of the full Merkleization, seems like the SSC isn't buying us a whole lot in the EL.
So we're almost through the entire call.
Does Matt want to drop another proposal, a simpler proposal? We can discuss that.
I think right now I'm marginally in favor of, I guess what we have, like I would have to look to double check, but I think that if we're computing the RLP, some RLP list of all of the elements prepending the transaction type and then K-check hashing that to create the signature, that's probably the best and simplest thing that we have at the moment.
I guess, yeah. And how big is it to like write that spec basically, or like I guess the PR to 4844?
Did we actually change the signature hash at some point to something else? Or was it something we were just talking about doing?
Originally, the signature hash was hash tree root. And then it was changed to just catch out the serialization to sort of be more compatible with the way the EL is already doing it. But I don't think it was ever RLP based. Mofi, I don't remember that. I'm reading from the chat, Mofi says it was RLP based.
But right now it's on DevNet, it's not RLP based. You guys are computing the hash tree root?
No, it's computing the Ketchek hash of the SSZ serialization, not the hash tree root.
I see. Yeah, I would be against doing the K-check of SSZ serialization just because this is something that is not done anywhere else. And it just seems weird. Like that is one of these examples where I feel like we're like stepping partially into SSZ, but not like the full correct way. So I would rather do kind of what Eton is proposing with a full SSZ signing mechanism with the hash tree root, or falling back to doing what kind of already exists, which is the RLP list.
Alexa, oh, Andrew, okay.
Oh yeah, I just wanted to say that, yeah, I agree with Lightline. So we either should revert back to RLP or go the full way and like to think about SSZ, like a proper path to SSZing everything and invest more time in just making sure that things like 6493 is actually a good way forward. But this kind of the current approach, which is half measure, doesn't seem to be a good approach.
Yeah, it would be probably good and helpful if final scope of SSZ transition existed, and we could at least understand which part we can deliver with 4844 without a lot of remake after that. what is the final SSD gain like that?
Justin, you also have your hand up?
Yeah, just real quick, I kind of wanted to, I think I agree with everybody, but I do want to point out that the intent behind the SSD adoption EIPs as they're written right now is for incremental adoption. So if we are, I think it would help us to say that we want to abandon that approach and pursue a big bang, knowing and accepting that the trade-off is significant delay in adopting SSD. So I think that's one thing to keep in mind, is that these half measures are by design.
Yeah, but what's the end? What are the goals of adopting SSD? What are we trying to achieve? It's like bringing an SSD library into EL is not a worthy goal. So, I mean, kind of, what are we trying to achieve?
Yeah, and honestly, I agree with that. I'm just kind of bringing up the other end of the argument. From my understanding, which is limited, is that what we gain is a generalized upgrade and adoption of what we broadly think is a superior serialization format. That's all. I don't have a stronger argument than that.
Yeah,
So
I mean, I
one-
agree. I agree with that as the goal, but I guess what it seems we're starting to realize is, are these half measures really even getting us there?
Right. I mean, hey, look, again, we're talking about mostly right now the signature signing scheme, which I don't think really matters all that much at the end of the day. When we start talking about 6404 and how are we going to, what is the actual transaction hash? What is the value that's going into the transaction commitment tree, whether it's Merkle Patricia or SSE? That's where that comes more into play, I think. But specifically, something that SSD helps with is being able to, in a smart contract, in some sort of fraud proof, be able to create proofs to specific pieces of the transaction without having to put the entire transaction object on chain. That is, I think, like the major thing that I heard from L2s, that they wanted to be able to prove a certain piece of the transaction. And right now it's not possible because you have to compute to get the commitment against the header in some way. You have to compute the K-check value yourself, which means you have to have the entire preimage of the transaction. With SSD, you can just use the hash tree root, prove like one specific leaf of that transaction.
So basically, the transaction signature can still be computed like gigak of SSD serialize, but the final transaction identifier could be the SSD hash tree root of the signed transaction type.
Yeah, and that's what 6404 is all about. It's about getting that fully Merkleized SSE transaction root in the header to allow for those kinds of proofs. So I think that is definitely a valuable goal, especially for L2 developers. I guess I'm not sure which way best gets us incrementally towards that, or if this is helping at all, I guess.
I mean, maybe we need to see some use cases. I think that would sort of bring an conclusive end to the discussion what we need.
Oh, I think for that particular case, there's use cases in fraud proofs, for example, being able to single out the specific part of the transaction. So I think there's known value for having a SSE with a Merkleized root available for proving over parts of it. But how do we, I guess the path there, right? Are these decisions we're making now hindering or helping our path there? I think that's what I'm a little fuzzy about.
I would like if anyone has a strong argument for adopting this as a Z-based signature scheme to, try and flush that out, because if there's not a strong argument and we're just doing it just to do it, then to me that doesn't make a lot of sense. And it might be better to stick with the formats that we have.
As was said, it can be a good tool for L2s to have some partial calculations of parts of the transaction of hash root to be transferred to.
But the
L1.
signature hash isn't available in the consensus any consensus mechanism. Like, it's totally opaque.
So these parts, partially calculated root is not used in contract like that. It is needed just in communication with consensus layer by L2s, right?
I'm not sure if I'm following. I'm talking about the message hash that the user ends up signing to create the signature. And I don't think that that value is propagated anywhere. It's reconstructed every time by the consensus nodes or the execution layer nodes to validate the sender of the message, but it's not something that's communicated to the CL or L2s.
I guess, okay, so we just have 5 minutes left. Does it make sense to pause this conversation here? Obviously, keep chatting on the ETH Magicians in Discord, and aim to like align on the overall SSZ approach for DevNet 6. Like, obviously, we shouldn't, change DevNet 5 overnight with this, but it does seem like a significant enough thing that if we make this our focus in the next couple of weeks, we can hopefully get to a spec we're happy with, and have the next DevNet implement that. Does that make sense to people?
Yeah, I think this is one of this, as well as I guess the blob transaction rebroadcasting on reorgs, are sort of the two main open issues that I'm aware of anyway. But yeah, I guess we should probably move on given the limited amount of time left, and try and have that on the Discord for now. I'll try to lay out a few of the discussion points and options that were discussed.
Awesome. Yeah, that would be amazing. Thank you. Yeah, okay. I think those were all the spec discussions that we had. So there was the PR. I guess Ethan had a small PR to 4844 that just changes the limits on.
Yeah, it's just a bug. I think it's just he's just fixing a bug.
Yeah, exactly. Yeah, so that's okay. Okay, I guess then in terms of DevNets, it might be worth just getting a quick update on DevNet 5, where different teams are at, and obviously for DevNet 6 we can discuss that once we have the SSZ figured out. But any thoughts?
One last spec thing. I mean, the same argument that we sort of made against doing the cage hack of some SSZ serialized value for the signature hash is the same argument for doing it for the transaction hash that goes into the Merkle Patricia try right now. So like, I am again like very against doing this like half in, half out, where we kind of introduce SSZ, but we don't use the correct way of hashing the SSZ object, which is the hash tree root, and we're just plopping that into the transaction try. So I would rather again go the full length, or only go not do the SSZ.
Okay. Okay. I guess, yeah, okay, quickly, any very quick updates on DevNet 5?
Nothing changed since Thursday, I would say.
Okay. And then I guess, okay, so as we wrap up, we're just highlighting there's this tool that was shared in the agenda. So if people want to check that out, I don't think the author is on the call. And then last thing, so Roberto, you just mentioned, SSZ, the reorg stuff are like the two biggest open issues. Obviously, Peter's had a bunch of comments about the state of the crypto libraries on the Discord as well. I'm wondering, do people think there would be value in trying to have a more thorough checklist to track all these open issues? Sorry, I just saw your message. Okay, we can get back to that right after. But yeah, do people think there's value in sort of revamping the readiness checklist? We had this much earlier on. Last time I updated it was right before Austria. Or do we feel like, there's sufficiently little issues left to deal with that, obviously the actual edge cases get tracked in the tests, and then there's, a handful of other implementation issues, but it's not worth maintaining a whole other tracker for that.
I don't think a specific tracker for 4844 would hurt.
Okay.
I mean, I think last time we were here, it was, Danny had to remind us that this was an open issue around the blobs, for example, which is
okay.
Become top of mind. Perhaps if we had been tracking that, we'd be more on top of it, I guess. It doesn't need to be super detailed, but yeah, just sort of a list of remaining things to resolve to make sure we're making progress would help.
Okay, I'll take a stab at updating the one that's there and kind of bringing it up to date this week.
Right, but like the crypto library issue, I've been following discussion around that. I believe Kev is working on that, at least in the Go library, but I don't know, if someone on the CKZG side is thinking about those concerns.
Okay, yeah, okay, so perfect. I'll update it. I'll share it once I have something, and obviously anyone's free to open a PR against it to tweak it as well, but I'm happy to own kind of the bigger update that since January. Okay, and I guess we hopefully got your name right. Do you want to take a minute to talk about your tool?
Yeah, sure. So we are experimenting the EIP-4844 DevNet, and so especially from smart contract side to see how to use it and also test it in smart contract. So one thing I found maybe missing is how to support this new OP code in a developer friendly. I mean, especially from smart contract developer friendly way. So I searched basically the implementation course, and I'm not sure there's any other tool that help to support this new OP code, and also definitely will takes time for the cities to support that. And if someone have more information of what they plan to support this new OP code, I'm glad to learn. So just start a quick, a small Solidity library that is able to deploy a customized assembly code to a smart contract and be able to get call the data hash, and then be able to return to the parent the caller smart contract, and so that we are able to retrieve the corresponding data hashes, and then use these data hashes and store in the, for example, in the ROA contract to experiment all these ideas of EIP-4844. So this is basically what we have done, and all the code is in the repo, and we have done the experiment test on the DevNet that following the Jimmy's notes, and happy to learn if there's any feedback or perhaps there's also other tools to solve the problem. Yeah.
There's a question in the chat. Can this be combined?
Can be date code combined with point evaluation become codes that I'm not sure the date code call is. I think is that the date hash of the code. Oh, I'm not quite sure. Combined with no, they're separate things. So data hash opcode is a new opcode 0x49. That is added in the list of the Ethereum EVM opcode to retrieve data hash corresponding to a block index. And the point evaluation precompile is a separate precompile that is added to support the polynomial evaluation of corresponding data block, given a list of data like KZG version hash and KZG commitment and also proofs. So basically, in terms of, like, for example, ROA, especially in optimistic context, so I believe the data hash is used to batch upload the data, and while if someone found that the transaction, the execution result on layer 2 is wrong, then they will call point evaluation precompile to upload a block, and then say, hey, there's some issue of executing this block on layer 2 and want to challenge. So this is basic two different steps used in rollup setup. Yeah.
Thank you. It was interesting how these pieces of code can be useful in 4844. Actually, it was not clear. Thanks.
Okay.
Cool. Anything else? Oh, anything else as we wrap up?
We have a couple of small updates from testing vectors I wanted to share. Is that fine? Or
Yeah. Go ahead.
Yeah. So I shared 2 links on the mini chat. The first one is the execution vectors. So there was a new release by Spencer helped us out to tag yesterday. Basically, it contains the Cancun vectors, and you can use this on the 4844 any client, any execution client that supports 4844. And we also have the Hive test suite. It contains right now 5 test vectors for all the execution clients who want to run this. If you need some help to run a specific Docker image of your execution client, please let me know. I can help you out to run any of these vectors. Yeah, that's all.
Cool. Thank you. Anything else? Okay. Well, thanks everyone. Yeah. Talk to you all soon.
Thanks, Tim.
Thank you.
Thank
Bye-bye.
you. Yeah.
Hey guys.